Assalamu alaikum, dear students. How are you? Welcome to the channel, The Physics Gurus. So we are here on the episode number 11 of the IGCSE Physics and O-level Physics definitions regarding with the syllabus 2022. So in this part number 11 or episode number 11, we will discuss the definitions of unit number 19, current electricity, unit number 20, DC circuits, and unit number 21, practical electricity. So let's start discussing these definitions one by one. So unit number 19, current electricity. The first definition is of the definition of electric current. The rate of flow of charges is called as electric current, and the formula of current is equals to I is equals to Q over T. I represents the current, Q represents the charge, and T represents the time. The unit of current is ampere. There are two types of currents in general. The current which flows from positive to negative terminal of the battery is called as conventional current, and this is due to the positive charges, while the current which flows from negative terminal to positive terminal of the battery due to negative charges, that is electrons, is called as electron current. Actually this current exists, but since we are using it as a convention, earlier scientists were not able to find that there exist an electrons, so they have concluded that current flows due to the flow of positive charges, and by default we have to mention the conventional current in the circuits while drawing the circuits and the flow of current in those circuits, until and unless it is stated that draw the flow of reason of actual current. So these two currents are equal but opposite in direction. So this current, the current which flows due to the positive charges from positive to negative terminal is called as conventional current, and the current which flows due to the movement of the negative charges, that is electron, from negative to positive terminal is called as electron current. This current actually exists, but by default we have to mention the direction of conventional current in the circuits. Ammeter, a device which is used to measure the current, is called as ammeter. Though sometimes values are given of the current like this, 30 milliampere. So in order to solve these question related with electric current, we have to convert milliampere into amperes. So make sure that whenever some sort of prefixes are given, you have to convert them into standard form. Ammeter, a device which is used to measure current, is called as ammeter, and ammeter is represented by this, and it is always connected in series in circuit at anywhere in the circuit. Let's suppose if I am going to draw this lamp over here, then I can place the ammeter over here. So ammeter will be always connected in series circuit, and this is the symbol of bulb. Voltmeter. A voltmeter is a device which is used to measure voltage, potential difference, or EMF. So there will be a difference between potential difference and EMF. I will explain it later. So it is always connected in parallel. And if we want to find the potential difference across the bulb, then we have to place the voltmeter like this. So ammeter is always connected in series, voltmeter is always connected in parallel. Then a very important definition in the definition of electromotive force, EMF, work done by a unit. Okay, work done by a unit positive charge as it moves around a complete circuit, closed circuit, or through battery. And the formula of electromotive force is EMF is equal to work done over charge. So you have to write down any of the following terms: that work done or energy provided by a unit positive charge as it moves around a complete circuit, closed circuit, or through battery. While the definition of potential difference is like this: work done on a unit positive charge. This was the by a unit positive charge, and this is the work done on a unit positive charge. It is as it moves around the component. What does component mean? It can be a bulb, it can be a resistor, it can be a lamp, etc. The formula for both of the term are the same. EMF is equal to work done over charge, potential difference is equal to work done over charge. Now, if we will put voltmeter across the cell, then this will give the value of EMF. And if we will put it across the component, then this will give the value of potential difference. Then a very famous and very important and very basic law of current and electricity, that is Ohm's law. Current passing through a conductor is directly proportional to the voltage, provided that, now you may write one of the condition, provided that temperature of the conductor remains same or physical condition of the conductor remains same. But it is always preferable that you may write the first condition. You can write the second condition as well. There is nothing wrong in that. And the equation of Ohm's law is V is equals to IR. V stands for voltage or potential difference, I stands for current, and R stands for resistance. Okay, now what is the definition of resistance? R is equals to V over I. So it is the ratio of voltage to current. What is the definition of resistance? It is the ratio of voltage to current, and the unit of resistance is ohm. Actually, resistance is the property or characteristics of a substance which opposes the flow of current passing through the conductor. So what is the formula of resistance? R is equals to V over I. And what is the definition of resistance? The ratio of voltage to current is called as resistance, and its unit is ohm. When we draw the graph between voltage and the current, since these two quantities are directly proportional, so the graph will be a straight line like this. Then relation between resistance, length, and cross-sectional area. Resistance and length, these two quantities are directly proportional to each other. When length increases, resistance of the conductor also increases. When length decreases, resistance of the conductor also decreases. And what is the relation between resistance and cross-sectional area? These two quantities are inversely proportional to each other. When cross-sectional area of a conductor increases, resistance of that conductor decreases, and vice versa. Very important relation, and in many questions it is being evaluated. Then DC circuits. There are two types of circuits which are in the syllabus, that is series circuit of resistances and parallel circuit of resistances. In series circuit, we can combine the resistors like this, positive and negative. How many resistors are there? 3, R1, R2, R3. Now in series circuit, current passing through each resistance remains same. What is the reason? That there is only one path for the flow of current. So if V is the voltage of the battery and I is the current, then current passing through R1 will be I1, R2 will be I2, and through R3 will be I3, but all these currents will be equal. I is equals to I1 is equals to I2 is equals to I3. And what is the reason? In series combination, current passing through each resistance remains same because there is only one path for the flow of current. But in resistance, voltage across each resistor will be different, and it depends on the value of resistor used in the circuit. So in series circuit, V is equals to V1 plus V2 plus V3. So when we will add it up, these three voltages then this will give us the voltage of the battery. Now, how we can calculate the current? Okay, in series circuit, total resistance can be calculated by this. R is equals to R1 plus R2 plus R3. So let's suppose if there are three resistors, 20 ohm plus 20 ohm plus 20 ohm. So the total resistance of the circuit will 60 ohm. And how we can calculate the current passing through the circuit? V is equals to IR, and we will use this value, and I is equals to V over R. So in this way we can calculate the current. So what are the properties or characteristics? In series combination, total resistance can be calculated by adding them. So total resistance increases and obviously current decreases. Overall current decreases as we are going to add up the resistors. So overall current of the circuit decreases. In series combination, current passing through each resistance remains same. Why? Because there is only one path for the flow of current. In series combination, voltage is equal to the sum of the voltages across each resistor, that is V is equal to V1 plus V2 plus V3. And in series combination, how we can calculate the current? By using the formula I is equal to V over R, and where R is the equivalent resistance or net resistance or total resistance of series combination. Now here comes the parallel combination. R1, R2. Now in parallel combination, we can calculate the total resistance by using this formula. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Some students are supposed to find the value of 1 over R in this combination. That is wrong. We have to find the value of R. Let's suppose if there are 10 ohm resistance connected in parallel combination, then 1 over R is equal to 1 over 10 plus 1 over 10, and then 1 over R is equal to 2 over 10, and they are supposed to write down the answer like this. No, this will be the wrong answer. You have to invert it now, then you will get the answer R is equal to 5 ohm. So in parallel combination, resistance, total resistance of the circuit decreases. Why? Because there is a reciprocal of the resistance. Now you can see that if this is the voltage, so then voltage across resistance R1 will be V1, voltage across resistor R2 will be V2, and it is the property or characteristics of parallel combination of the circuits that in parallel combination voltage across each component remains same. And the reason is that because all left sides are connected with the positive terminal of the battery and all right sides are connected with the negative terminal of the battery, so they are at the same potential. But what happens to the current when current reaches over here, this at this point? Now current can flow in upward direction as well as in downward direction. So current has been now splitted, and it depends on the value of resistance used in the circuit. Now again, here the current will be I1, the current will be I2, and once again, when it is merged over here, then again it becomes equals to I. So total current will be I is equal to I1 plus I2. So the property or characteristics of parallel combination is entirely opposite to the properties and characteristics of series combination. In series combination, resistance increases. In parallel combination, resistance decreases. In series combination, current remains same. In parallel combination, voltage remains same. In series combination, voltage across each resistance varies depending on the value of the resistor. So total voltage we can calculate by adding them. But in parallel combination, current is being split. Why? Because there are alternate paths for the flow of current. Current can flow in this direction, current can flow in this direction. So current will split or divide. Okay, ji. Then here comes a very important part of the combination, and that is potential divider. What is meant by potential divider? This will be like this. We can divide or split the voltage by combining two resistors like this: positive, negative voltage. This is R1, this is R2. This voltage will be V1 cross R1. This voltage will be V2 cross R2. So what are the formulas to calculate the voltage across R1 and the voltage across R2? V1 is equal to R1 over R1 plus R2 into V. What was the V? V was the total voltage of the battery. And for V2, the formula remains same, just only the difference is there. For V1, we will use R1. For V2, we will use R2. And then ratio of voltage to resistance will be the same. That is R1 over R2 is equal to V1 over V2. Then here comes the next part of the current electricity topic, that is practical electricity, electric power. What was the definition of power? Rate of doing work is called as power, or energy per unit time is called as power. But what is electric power? Energy provided by current in unit time. P is equals to E over T. And the same unit will be there. That is, electric power is also calculated in which unit? Watt. Kilowatt hour. Joule is the small unit of the energy. When we measure, when we get the current energy from the current, because current is a source of energy. So we cannot measure that energy in joules on the larger scale. So we have to define a new unit of energy, larger unit of energy, that is kilowatt hour. So what is the definition of kilowatt hour? Energy provided by power of 1000 watt. Why? Because 1 kilowatt is equal to 1000 watts. And what will be the duration in 1 hour? There are three types of wires in this electricity topic: live wire, neutral wire, and earth wire. Live wire, a wire which is a higher potential or at 220 volts and it causes the electric shock, is called as live wire, and it is a dangerous wire. Neutral wire, a wire which is at lower potential or 0 volt, and this wire provides the return path for flow of current. Definitely current flows from higher potential to lower potential. And the third wire is earth wire, a safety wire which protects us from electric shock when current passes through metallic part of the conductor. What is the fuse? A fuse is a safety device which is used to limit the flow of current, and its symbol will be like this. Then there are multiple formulas or famous formulas. Power is equal to energy over time, and P is equal to I into V. Then P is equal to I square R. Then P is equal to V square over R. Then different formula of energy: E is equal to PT, E is equal to I into T into V. Or E is equal to I square RT, E is equal to V square over R times T. Then formula to calculate cost of electricity is equals to number of units multiplied by price of 1 unit. Now, how we can calculate number of units? Power in watts divided by 1000 multiplied by time in hours. Why we have divided power by 1000? To make or to convert watts into kilowatts. And the same formula is used to calculate energy in kilowatt hours. And how we can calculate the fuse rating? By using the formula P is equals to IV and I is equals to P over V. I hope now these definitions are clear to all of you. So best of luck to you for your exams. Thank you very much for watching the videos. So keep watching these videos. Assalamu alaikum.